Hello guys, myself Abhay Kalodia and today we are going to learn basic definitions of AC fundamentals. So let's begin. The first definition is waveform. What is waveform? Waveform is the shape of the curve obtained by plotting the instantaneous values of voltages or current as the ordinate against time as abscissa is called its waveform. So let's understood by this a simple wave. Here the ordinate is nothing but y-axis and abscissa is nothing but x-axis. So by plotting and joining the values of sine 0, sine pi, 3 pi by 2 and pi, we get a wave and shape is nothing but its waveform. So there are different types of waves such as sine waves, complex waves, triangular waves and square wave. So next definition is cycle. One complete set of positive and negative values of an alternating quantity is known as cycle. One cycle corresponding to 360 degree or 2 pi radian. So here we see that positive value of sine wave is from 0 to pi and negative value is from pi to 2 pi. So by combining these two waves, we get one cycle, which is from 0 to 360 degree or 2 pi radian. So next definition is frequency. The number of cycles that occur in 1 second is called the frequency of the alternating quantity, measured in cycles per second or hertz, or 1 hertz is equal to 1 coulomb per second. So as we all know that in India we have a frequency 50 hertz. Why is this so? So basically in 1 second there is repetition of a cycle 50 times. So it makes the frequency in India 50 hertz. You can just imagine how the fast electricity is. So it is given by the formula frequency is equal to 1 upon time period and its SI unit is hertz. So fourth and important definition is time period. The time taken in seconds to complete one cycle of an alternating quantity, it's called its time period. It is generally represented by T. Now time required for a wave to reach 2 pi to reach this wave from 0 to 360 degree or 2 pi radian is nothing but time period and its formula is T is equal to 1 by F. From above we have shifted this T to the left hand side and F to the right hand side and its SI unit is second. So next the most important definition, that is amplitude. The maximum value that is positive or negative attained by an alternating quantity is called its amplitude or peak value. Remember this word, that is peak value. It is also called as peak value. The amplitude of an alternating voltage or current is designated by Vm, Em or Im, means it is represented by Vm, Im or Em. So let's understood this by a wave, simple sine wave. So here the positive value of sine wave is 1, which is maximum, and negative value of sine wave is -1, which is minimum. So here which is known as the amplitude, and here we may notice that peak to peak value. What is the peak to peak value? It is nothing but from the wave you can observe that it is the value from positive wave positive peak value to the negative peak value, or it is generally 2 times peak value. So next definition is instantaneous value. The instantaneous value of an alternating voltage or current is the value of voltage or current at particular instant. Remember this word, this is particular instant. So for example, if you see the above graph, the value of sine 3 pi by 2 is -1. It means that the value at any instant or any point is nothing but instantaneous value. Next, very important, that is average value. The average value of an alternating current or voltage is the average of all the instantaneous values during one alteration. It is equal to 0.637 times of peak value. Now how this equation I average equal to 0.637 times peak value is obtained. So let's derive the equation. As we all know that average of any wave is nothing but average of any wave is nothing but area under curve divided by length of curve. So consider this waveform from 0 to pi. So its area under curve is given by Im sin theta. Basically, we know the equations of Im and Vm. Im is nothing but Im sin theta and Vm is nothing but Vm sin theta. So Im sin theta divided by length of curve, that is 0 to pi. It means pi. So now this wave is starting from 0 and ending to pi. So we'll integrate it from 0 to pi. So this 1 upon pi will come outside. 1 upon pi integration of 0 to pi Im sin theta d theta. Here we are integrating with respect to d theta. So Im will come outside integration. It will become Im by pi, and we all know that integration of sine theta is minus cos theta from 0 to pi. So on putting the values, we get Im by pi is nothing but minus minus cos theta, the value of cos pi minus value of cos 0, right? So now finally we will have I will write here Im by pi. So value of cos pi is -1. So minus 1 minus, also value of cos 0 is -1. So -1. So we will get here minus minus become plus, and here also it become plus. So we will get finally we will get Im by pi into 2. On further calculation, 2 by pi is nothing but 0.637. So we will get I average, that is I average value is equal to 0.637 times peak value or amplitude. Next what, that is root mean square value. The RMS value of sinusoidal alternating current is 0.707 times the maximum or peak value or amplitude of that alternating current. It means IRMS is equal to, how this has come, IRMS is equal to IM, that is peak value or maximum value, divided by root 2. So 1 upon root 2 is nothing but 0.707 times peak value or maximum value. So thank you.
Hello everyone, myself Manasi Goresar, and I'll explain the next topic, that is mathematical representation of sinusoidal voltages and currents. So what is a sinusoidal voltage? The voltage which changes with respect to time is called sinusoidal voltages. As in AC circuits, The flow of charge changes periodically. As a result of it, the voltage level also reverses along with the current. Hence, we get sinusoidal voltage. Sinusoidal voltage are represented as given below in the graph. The graph shows that at 90 degrees and 270 degrees, it is attaining the maximum value, or we can say the peak value, and at 360 degrees, it is completing one complete rotation, or we can say one complete cycle. Next is mathematically how we can represent sinusoidal voltages. First, in terms of maximum value, V is equal to Vm sine theta, where Vm is the maximum value of the voltage, or we can say the peak value of the voltage, and theta is the phase angle. Next, in terms of maximum value and angular velocity, V is equal to Vm sine omega into t. Theta can be written as omega into t. Omega is nothing but angular velocity, t is the time period. Next, in terms of maximum value and frequency, V is equal to Vm sine 2 pi f into t. Omega is written as 2 pi f and t is the time period. F is the frequency. Next, in terms of maximum value and time period, V is equal to Vm sine 2 pi upon t into t, where f is written as 1 upon time period. Next is sinusoidal current. So now, what is sinusoidal current? Sinusoidal current is the current which changes periodically both in magnitude and direction. That means, as we can see in the graph, the charged particles or the motion of charge in AC circuits is starting, or it tends to start from 0, and then it increases to a maximum value. As we can see, it is starting from 0 and it is increasing to a maximum, and then it again decreases back to its 0, completing one positive cycle. The particles then reverse their direction and they reach the maximum value in the opposite direction, after which it again returns to its original value, completing a negative cycle. So hence, the same cycle, that is the positive cycle and the negative cycle, is repeated again and again, as we can see, and hence from this, alternating currents are also accompanied by alternating voltages. Okay, and besides these alternating currents, they can easily be transformed from a higher voltage level to a lower voltage level. These sinusoidal currents can also be mathematically represented first in the terms of maximum value, that is I is equal to Im sine theta, where Im is the maximum value or the peak value of current, theta is the phase angle. Next, in terms of maximum value and angular velocity, I is equal to Im sine omega into t, where omega is nothing but angular velocity and t is the time period. Next, in terms of maximum value and frequency, I is equal to Im sine 2 pi f into t. Omega is written as 2 pi f, t is the time period, f is the frequency. Next, in terms of maximum value and time period, I is equal to Im sine 2 pi upon capital T into t, where f is nothing but it is represented 1 upon time period. So from this, we studied how we can mathematically represent sinusoidal voltages and currents, and also how graphically they are represented. Thank you.